Welcome to Bite-Sized Data Science. We're making progress on our spatial knowledge. In this video, we'll talk about geocoding and about different types of spatial objects. Let's get started. In brief, geocoding is the process of transforming an address into its equivalent spatial coordinates, meaning longitude and latitude. The reverse process can also be done and is called reverse geocoding. There are many geocoding services, with some of them providing free services for low volume of queries. Let's get into a notebook. I am using the IBM Watson Studio environment to run my notebook. If you are interested, you can find a link in the description on how to create a free account on that platform. Links to the notebook I'm using here are also available in the description. For geocoding, I'm using the GeoPy library. The coding is actually done by a specific service. As we can see, we have a choice of 24 different services. I picked Nominatim since it allows me to geocode without having to create an account. I did try several services and decided to keep everything in the same notebook. The first step is to get our geolocator based on the service we want. Nominatim requires one parameter that gives a reference name to your application. I simply use the name Geocoding Notebook. We can see that we now have an object of type Nominatim. The location I picked is a store in Beaverton, Oregon named 5 Star Guitars. We see the return value where the address includes additional information, and we get the longitude and latitude. The location object includes a raw member that, in the case of Nominatim, includes quite a bit of information. You can see all the methods and members available in a class using the dir command. We can also do the reverse operation and get an address from the longitude and latitude. Interestingly, we did not get the same address, and the spatial coordinates returned in the operation are also different from the ones passed in as parameters. If we calculate the distance between those 2 points, we find that they are 265 feet apart. Let's investigate. Through other means, I got the geolocation of 5 Star Guitars. When I reverse geocode it, I actually get the freeway behind the store. Let's look at these 3 points visually. For this, I'm using Folium to display a map with markers. The first marker is the location I was expected to get, 5 Star Guitars. The one lower on the map is actually the location I got. Finally, the third location is what I found through the reverse geocoding. Why is that? For one thing, an address is not a point. It is more of a polygon that represents an area. The geocoding is as good as the database behind it. When a specific address is not in the database, the system tries to estimate its location based on other known addresses or objects near it. In the case of Nominatim, the engine behind it is OpenStreetMap. The quality of the data depends on the work of volunteers. In this case, more work could be done to improve the quality of the service. In another test using Mapbox, the geocoding and reverse geocoding ended up 2 inches apart, and both points were in the 5 Star Guitars store. Let's move on to the next topic, spatial objects. We just saw that an address is really not a point, but is really represented by a polygon. There are many objects that can be represented, and to accommodate this, there are multiple types of spatial objects. This includes points, line strings, polygons, and there are multiple, such as multi-polygon. Finally, we can also have a collection of objects called geometry collection. Let's look at an example. To process spatial data, I'm using a library called GeoPandas. Yes, it is like a specialized pandas data frames. I read in 5 cities from the Chicago area. You can see that I have their latitude and longitude, but I also have either a polygon or multi-polygon as part of the definition. Let's see what that means on a map. A city is not a clean rectangle. It can be quite convoluted. Just look at poor Norwich that is surrounded by Chicago. Also, Chicago only has a road connection to make sure that the O'Hare Airport is part of it. Now, look at the markers from each city. Yes, the markers are within the city limits, but when you are going to Chicago, you may be surprised when your GPS says you have arrived. Being able to have exact geographies for cities, zip code, counties, state, and more can be crucial in some business problems. So we've learned about GeoPy to do geocoding, and we know that we must think of spatial data as more than points. More to come. See you next time on Bite-Sized Data Science, and don't forget to subscribe.